Hello. In this session, we'll be discussing about filtration and radiation, which is a physical method of sterilization. We have already discussed about heat sterilization and its uses. Now we'll be discussing on filtration and radiation. Filtration is a physical method of sterilization used for sterilization of substances which cannot withstand heat or which will be decomposed by heat. And usually the sera, sugar solutions, body fluids, etc. will be decomposed by heat. So we can rely on filtration as a method of sterilization while preparing media as well as preparation of vaccines. We're coming to the details of types of filters. We have different types of filters, earthenware cantle filters, asbestos filter, sintered glass filter, membrane filter, air filters, etc. We'll look into one by one. Candle filters. They are earthenware filters manufactured in different grades of porosity and made in the form of hollow cantles and used for purification of drinking water for industrial purposes. And the types of candle filters are diatomaceous earth filters, which is made from the skeleton of diatoms. Example is Bergfield filter, and we also have porcelain filters. The example is Chamberlain filter. Second one is asbestos disc filter. From the name itself, it is clear that it's made up of asbestos. Seeds filter, which we used in earlier days, is an example for asbestos filter. Asbestos is chemically magnesium silicate and it has got a high absorbing capacity, but it has been discouraged due to carcinogenic potential. Third one is sintered glass filters. Sintered glass filter means it's made up by fusing glass particles, and this is also available in different pore sizes. And the next one, that is membrane filter, which is one of the most important, and now it is the commonly used method of filters. Membrane filters is made up of cellulose esters, cellulose acetate and cellulose nitrate. And nitrocellulose membrane filters are more widely used nowadays. It's also known as millipore filter. Millipore filters are used for sterilization of antibiotic solutions, sera, and any other body fluids, etc. Millipore filters are available in pore size of 0.015 to 8 micro diameters, and 0.22 micrometer diameter is the most commonly used, and it has got a high filtration rate, that is within a short duration you can filter quite a large volume of liquids when passed through this filter. And the solution to be sterilized is usually forced through filter with the help of vacuum pump or syringe. You can see the filters, millipore filter, that is in the center. You can see the filter. It's like a chromatography paper. But the microscopic diameter, the pore size is very less. It's only 0.2 microns, which holds back the bacteria. And this is the setup. And you force the liquid with the help of a syringe through this pore. The uses of millipore filter is it's used for water purification, analysis, sterility testing. Also, you can estimate viable counts of bacteria. I have already said that the bacteria will be held back on the filter paper so that you can take out that filter paper and place it on a culture media, so that if any bacteria is present within the filter paper will grow on the media, and we can estimate the viable counts. And also the size of the virion also can be measured. Next is air filters. Air filter is used to deliver clean air into a room or in a microbiology laboratory. And these air filters are commonly used in a laminar airflow safety cabinet. Laminar airflow chamber is a chamber which we use for inoculation purposes, which we perform the inoculation of cultures within a laminar airflow chamber. So this ensures safety to the personal as well as a product, because particulate air filter is present within the laminar airflow chamber, which ensures sterile air in the environment. So you can see the laminar airflow chamber, which is used for inoculation or working in a microbiology laboratory, and these are the filters. Air filters are placed on the back wall so that it sucks in the contaminated air and delivers sterile air. And this air filters can deliver particles of 0.3 micrometer or larger. Now summarize the uses of filtration. Filtration is used to sterilize syrup as well as sugars and antibiotic solutions which are decomposed by heat. And it is used for separation of soluble substances from bacterial culture, like toxins can be removed with the help of filters. Also, bacteria-free filtrate can be obtained for the cultivation of viruses. And it's used for purification of water as well as to estimate viable counts of bacteria and measure the size of virions. We can use filtration. So that's all about filtration. Next, we'll move on to the last one, that is radiation. Radiation, which is another important physical method of sterilization. And radiations means that we have already learned about the ionizing, non-ionizing radiations within an electromagnetic spectrum. You can see the electromagnetic spectrum, and here it's split into non-ionizing as well as ionizing radiations. Ionizing radiations cause ionization, whereas non-ionizing radiations does not cause ionization. Ionization means it is a removal of electrons from atoms or molecules, and ions are released. And so both these radiations, which comes under the electromagnetic spectrum, can be used for sterilization purpose. We look into the details. Electromagnetic waves used for sterilization are known as radiations. And the two types of radiations which are used for sterilization are ionizing as well as non-ionizing radiation. And the ionizing radiations, we have the X-rays and gamma rays, whereas under non-ionizing radiations, ultraviolet radiations are the most commonly used. Coming to the details of ionizing radiations. Ionizing radiations are of short wavelength and high energy. And the source of ionizing radiations is cobalt-60, that is gamma rays from cobalt-60. And from the name itself, we know that it causes atoms or molecules to ionize. Hence, it is known as ionizing radiations. And the mode of action is these ionizing radiations induce lethal changes in DNA by photochemical reactions. It also causes double-strand breaks in DNA, and which leads to mutations and ultimately death of the bacterial cell. And the ionizing radiations has got a high penetration power and the efficiency is very high, but since it does not develop heat or does not cause an increase in temperature, and the sterilization by ionizing radiation is known as cold sterilization. And the uses of ionizing radiations for sterilization are: it can be used to sterilize heat-sensitive medical devices such as masks, catheters, plastic syringes, which cannot withstand heat, can be sterilized within an ion using ionizing radiations. Next is non-ionizing radiations. Ultraviolet radiations are most common non-ionizing radiation which are used for sterilization purpose, and the wavelength is between 240 to 280 nanometers are most commonly used, which has got bactericidal activity. And the source of UV light is low pressure mercury arc lamp. But compared to ionizing radiations, the non-ionizing radiation has got low penetration power. And the mode of action of non-ionizing radiation or ultraviolet radiation is that it causes thymine dimers to form between adjacent thymines within a single strand of DNA, whereas ionizing radiations cause double-stranded breaks. Non-ionizing radiations cause single-stranded breaks, and it also causes denaturation of protein as well as interfere with DNA replication. This is single-strand breaks within a thymine dimer. Now coming to the uses of radiations or ultraviolet radiations. It is used for disinfecting bacteriological laboratories. We have an UV lamp which is present within the laminar airflow chamber. This is seen in the picture. And inoculation hoods also contain this UV lamp which helps in sterilization of the work area. Also, operation theatres and drinking water supplies also utilize ultraviolet radiations for sterilization purpose. So that's all about the radiations. Hope all of you have understood. Thank you.